Why can't my model just simply understand what is positive versus negative, and then I can not even apply on sentences, I can apply on paragraphs, I can apply on meeting calls, I can apply on Twitter, wherever. The real thing which really unlocked here is that people have figured out that you don't need to label the data.
What has changed in the last 5 years, particularly in the domain of the text? We are primarily focusing just on last 5 years so that we know what may be coming next and what has already come, how we can utilize it, or how other companies or products have been utilizing it.
So the first thing is, what are foundational models? Any thoughts in the room? What are foundational models? Anybody has? How many of you have heard this term, foundational models? Okay. Oh, cool. I will tell. Anybody wants to take a shot at what is a foundational model in one line? No?
General purpose, not fine-tuned for any particular domain.
So,
I'm not techy, but what I've understood, and I'll be glad if you correct that understanding, it's like neural networks which you create so that those embeddings give you results. And how those results come is depends upon what you fine tune and stuff. That's what
close. But yeah, this is more closer that you train the model. I mean, you can train the model through neural networks, but over the time, models can acquire general purpose ability, where you really don't need to train a lot for specific tasks. Like for example, the way traditional machine learning used to work is that, let's say you want to do a simple sentiment classification. Given a sentence, I want to say whether that sentence is positive, negative, or neutral. That's a very small problem, right? People have spent PhDs around that problem, right? But the idea is that a lot of grunt work was on acquiring the data, then training your model just for that task. And someday people figured out that maybe it's too much effort for a small problem. Why can't my model just simply understand what is positive versus negative, and then I can not even apply on sentences, I can apply on paragraphs, I can apply on meeting calls, I can apply on Twitter, wherever. Right? That's what the foundational model brings to the table. So, these are large neural networks trained on large amount of parallel untrained data. The real thing which really unlocked here is that people have figured out that you don't need to label the data. So I don't have to say this sentence is positive, negative, or neutral. I can just say, hey, here is a sentence, do some manipulation on that, and then you learn. And over time, I can prompt you with the right examples, and you will figure it out what it is, right? And of course, some of these things might look really off the head, but you will get a sense of that. So, yeah, I talked about, so they are more adaptable. So think of this, right? Think of this. We have whole big internet around it, right? So if you really reason with somebody that's saying, hey, what happened? Like, why are the foundational models coming now versus 1980s? You know, we called it as a AI winter. AI summer was in 80s before this, right? In 80s, people were trying to look at, hey, can I transcribe the speech, right? Like, you will see a lot of old papers, right? Neural networks was in 80s, right?
I think Microsoft acquired Skype was somewhere.
No, Skype was way later. It is somewhere in 2000, 2010. But 80s were where like really old speech models, if you find, is coming from there. Turing test was in 50s, where somebody really predicted that there is going to be a machine which will act like a human, right? So it's an old story, but things which have got played out is really this, where you could acquire a lot of this data, right? Data in digital sense. Data was always existing around us, but now data exists where? Where is the maximum data exists today? Internet, right? So a lot of this data actually became digital. People collaborated, they didn't know what to do, but they was writing on internet, creating. And unknowingly we have put the largest data repository that we ever had on digital. Somebody has figured out that, okay, if we put enough compute on this data and a reasonable model, or reasonable algorithm, we can do amazing things. And that's what really happened. Once you have put enough compute and a reasonable algorithm, you could unlock a lot of these things, like the sentiment analysis that I was talking to you about is pretty much off the shelf now. You can just dump your customer reviews in a piece of Excel sheet, give it to ChatGPT, it can label you without even telling you. You don't even have to tell you label, just put a column name which saying sentiment. Right? It will figure out what does the sentiment mean. That's the foundational ability. That foundation model. Right? That you don't need to train task-specific models. You can have a general purpose model. Our traditional ML was very task-specific, right? Every task was I have another talk after this, and you will see a very nice cartoon there. If somebody comes and tell you that, hey, here are the bunch of photos, can you label them from where they captured? And then the usual thing that today you will think, oh, I will look at classify all of that. No. Previous 5 years back, 10 years back, you will like, hey, are we also capturing GPS coordinates so that I can put in map? Right? That's the thought process. If I say, hey, if it is a bird highlighted, and then I like, hey, give me 5 years and a bunch of research engineers to work on that problem. Right? That was the limitation, right? Each and everything was a different model. People used to take years to solve that, right? And now, a lot of these things become off the shelf. That's where the iteration becomes easier, and that's the core capability of foundational models. Now, how do we use foundational models? I think one of the very popular ways of using foundational model is prompting. All of you have done prompting? Who has not written the prompt in this one? So if you have asked anything to ChatGPT, you have prompted. That's what it is, right? So there's nothing, right? There's all of you are prompt engineer. I mean, that's not a real role either way, but so you have prompted. The second way you can use this foundation model is fine tuning. Why do you need fine tuning? Fine tuning is that, look, the typical language model has learned from the piece of text, piece of images, but let's say I have learned something on images which is general purpose, but I want to use that model and apply it on X-rays. Right? That is where you need fine tuning, because my model has not seen enough data, but it has figured out how does a good image looks like. I want to do it on other sort of images. So then, wherever you need to go really deeply on some particular task, you need fine tuning. These are some of the foundational models. I think BERT was really foundational. How many of you have heard about BERT? Yeah. So the BERT was really foundational. That's the first time that somebody has said that, look, looking at a sentence, right? You don't need to label that. What you could do is take the one word out of that, and then let the language model predict that word. Right? And over time, you keep doing it, model will eventually learn how to replace words as well as how to predict the next word token, which is different kind of models, which some predict in missing words, some predict the next word. More popular are the next words ones.
Speech to text is a very good application for this.
Speech to text is not entirely this one. So BERT is a pure textual model. Speech to text is a little bit different. The GPT, right? All of you understand what GPT is, right? So that was built on learning the next word prediction objective, which is not the missing word, but the next prediction. So you say, cat sat on fill in the blank, right? And that's a mat, right? Most of the time, but cat sat on the table too, right? So basically what model is, when you give enough data to it, like internet scale data, it will randomly mask those things, right? And then try and predict. And because it can use that as an output variable to predict, right? That is where the learning comes from.
So what the attention is all you need paper was and GPTs?
Attention it was not on GPT, but it was a foundational technology which led to GPT. So one of the things that attention brought is that when you pass any sentence, like earlier what used to happen is that models were only looking at the immediate context, right? Just either the cat sat on the mat, all of that was getting combined and then using it. What attention brought is that it brought parallelization, that you can actually give some limited attention automatically, some weighing, like how much weight you should give to cat versus sat on the mat. So probably cat is more weighing word because there is some animal that is being talked about versus sat, which is not that important word, right? So the model eventually figure out how to distribute the weight. That's the attention. Okay, clip. This is again a vision model, large scale. But the idea is that there are different foundation models. How many of you think that what's the are foundational models only open source or are the foundation models only proprietary? Mix of those. Mix of those. Do we have more foundation models which are proprietary than open source, or which one is more? Open source. Where do you find foundation models? Hugging Face. Where else?
Together, yeah.
Sorry?
Together, yeah.
Together.ai? Maybe you can find that too. Yeah. So good. So that's what it is. But the idea is, one line summary is that foundational models in open source are growing at least 10x faster than proprietary models. So for builders, people who really want to build on foundational models, there has never been a better opportunity than this. Right? That's what the excitement is. Because the idea of open source to me is that even like big, if you look at Hadoop, whatever, or Apache, any Spark, right? They are open source software, but there are big companies backing it. Right? There is seldom you will see any open source software out there which is flourishing without a big company backing it or funding it or whatever, right? Like you see in browser, you see in big data processing software, most open source software has this kind of backing, right? And Facebook has this strategy. But related to your, I will tell you an anecdote, right? The GPT-3 came in, everybody was very, very excited. Bloomberg, which is a finance company, tried in creating BloombergGPT, right? Have you heard about BloombergGPT? It was created for finance tasks, right? And it was able to do a much better job in financial related things like financial forecasting or analyzing financial documents, right? And on benchmark, it has showed that look, we are much better than, let's say, GPT-3, which is a proprietary model. But for finance, BloombergGPT is the way to go. But as the proprietary is also moving, right? It's not static. So, do you know how many days or years that lead time on at least the benchmarks was there for BloombergGPT? 1 year. Less than 1 year. A new proprietary model came in, which has a better accuracy on those benchmarks. So the $10 million that was spent in training BloombergGPT. But it's also the overall learning space. If BloombergGPT has done that much work, created infrastructure to train the models, they can probably use to train more, right? Do something more interesting task. So it's not a waste of money itself, but it is the way how you need to interpret. This is a very interesting note. So how many of you had this scales law, or people call it different word? There is another one that people call it, right? Power law. So this all large language models generally follow this power law. It's like Moore's law that we throw in for the processors, right? So this is the power scale law, where the idea is that you continue to do through more compute, your loss keeps on decreasing, and that is where OpenAI was actually able to predict really well that look, if we throw this much compute, which is you can translate into dollars, if we throw this much dollars, our model will be able to do this capability, right? At a high level. So that's the compute, that's the data set size, that's the parameters. Parameters is a function of both data size and data set size and compute. Right? Now, at least for the large model, which has become very interesting, is that sometimes this curve is started to seem plateauing. Till this time, this was like a negative straight line. But now this has started to plateau, some of it. Well, again, somebody has to throw a lot of, like hundreds of millions of dollars to figure out whether it's really plateaus. But at least people are training the models, they tell that look, it started plateauing. So we don't know what is the, but the only way you can see this curve plateauing is by throwing those dollars, right? So, but this is very interesting, right? As you look to work in AI, you really need to know what's at stake, what my GPT-5 brings up, or what could be the next cloud version brings to the table, right? If they throw enough compute. So OpenAI has done a really good job. Like, I mean, people put a lot of premium on the output of the model, saying, oh, this is great, so much, so really well. But the hard work that they put in the back end to bring predictability in LLMs is amazing. I mean, they can really predict if we throw this much more, what will happen, right? Because that was a lot of uncertainty, even in traditional ML, nobody knew. Right? It was very hard to predict that if I throw in this much compute, what is the data that I will need? It was just guess estimate. So they have done really good job there. Okay, I will just quick to. So I think we have talked about this thing, right? That generalization, enhanced performance. I'm sure all of you know. Accelerated time to value. So I think all of you must have heard these, right? 80% of the machine learning projects fail and all of that, right? To some extent, right? So, but at least now what LLM brings to us is that your iteration becomes really fast. So you can see things, whether it really works on your use case or not, what sort of techniques that you want to go after, the availability of models, the diversity of models across different modalities is ever increasing. You never had these kind of opportunities, right? Yeah. So I think this is, again, some of these we have talked out earlier, but idea is pre-training is one, right? Pre-training is the way they are pre-trained, right? Like they are trained from the very start, like predicting next words, or taking out some portion of audio from that, or taking some part of frames from a video, right? That sort of thing. Fine-tuning is more instruction fine-tuning. So there are two set of fine-tunings. One is to the instruction that you can align the model into specific direction that you want. For example, you want it to adhere, like the way prompting capabilities came in is through instructional fine-tuning, right? Which is the model was asked that, look, given these instructions, you need to behave in this way, right? So I think some of you might have heard RLHF, reinforcement learning based human feedback. That's what you typically use at fine-tuning and alignment part of it, right? Where you try and align the model to instructions as well as preferences. Like if you ask me to write essays, the model could write essays. Like I'm talking about 3. So when 3 came in September 2022 or 2020, GPT-2, if you look at 2 or 3, you could see that it could produce text, but sometimes it was nonsensical, right? So grammatically it will look all right, right? But it will look, it looks really well written, right? But different sentences might be talking about one is earth, another is moon, right? Like literally wide apart. So that is where the alignment and fine-tuning really help. So when GPT 3.5 came in, they really took that RLHF thing high level, where they passed a lot of good data, human preferences to the model, so that model could distinguish that how to follow instructions as well as what good looks like, right, on different tasks. Another interesting thing is that as you keep training, the models achieve emergent ability. And emergent ability is just the same thing that we've been talking about, that it general purpose ability, right? But it's called emergent behavior in LLM space. That at some point of time, like for example, one way to understand this emergent ability is that if you have like a billion parameter general purpose model that does very poor on reasoning capability. Like if you take a Llama 7 billion model, that does very bad on reasoning. Like if you ask a math question or whatever, right? It does not do a good job. But if you, for example, you would ask a GPT-4, which is like several hundreds of billion parameters, I mean, they openly don't disclose, but it's like at least 200x or 20x more better model, that does good job. Llama 7 billion versus 300 billion. The emergent ability didn't emerge on a small number of parameters. Now, this notion can easily break, if I counter argue this thing, if you train the model on arithmetic task itself. Then it's a separate thing. Yes,
Exactly, like parameters.
Parameters is just you can say variables in the model. So it's a fixed set of things, it's just a float value. So parameters is the way, typically, that's a power scale law. So the another interesting thing about AI thing is that as the number of parameters increase in an AI model, it is considered to be more smarter. Anyway, so emergent ability is that if you keep training the model, it starts to do tasks which it was not trained to do that, which is a good thing. Right?
So just on parameters, so you can't define the parameters. जैसे अभी आपने arithmetic summation क्या आप वैसे नहीं define करते. आप कहते थे let's say cat. If I give that example, so cat has that different sort of columns and उसमें वो different weights मिलते हैं उसको.
नहीं देखो
parameters.
हाँ, the way you can think about it is that you have a language model which is really good at predicting the next word.
Sure.
So once you train a model, right, or a foundational model, text-based foundation model, the only ability that it acquires is just given a any text prompt,
Right.
it can predict the next word really well. I think we are a little bit lagging behind on time, but I will pass it to Rajat so to talk about more interesting stuff. Anyway, reasoning and planning is something that models are struggling even today, right? So GPT-401, right, is a model which is actually customized just to solve reasoning and planning, right? So because it's a and it still struggles, right, in many ways. So anyway.
We have already seen, we have get the foundation of some foundation models, and to build upon it, it's the different modalities how we are utilizing the foundation models. And the most common use case which, or the modality which hits our mind is the text, because we deal with a lot of text. And this is the theme what Kuldeep has been mentioning for this presentation, and it took me a while to get into it. So this is the one title that what has changed in the last 5 years, particularly in the domain of the text. So although we have a long journey of AI models coming from 80s till to 2024, but we are primarily focusing just on last 5 years so that we know what may be coming next and what has already come, how we can utilize it, or how other companies or products have been utilizing it. So in particularly with respect to text, one thing which has drastically improved is the context length. Yeah, maybe I can just add our use cases. Like previously the bird which came, it had the context window support of just 512 tokens. So it's not like few years back, hardly into 2019, 2020 when we were using bird for our applications, we were just able to process just 512 tokens. How it relates that I have a customer review, I am doing sentiment analysis on it. Customer review is a bit long, let's say 1000 words. Then I have to split it explicitly into 2 parts, and only then model can process it in 2 tons. But now we know that Claude has support of almost 200k, Gemini claims 1 million context length support, although it's not a practical thing, but what people are trying to increase the context length. How it is being done, maybe we can take it offline because it's again a bit technical stuff, but how it is helping I will be presenting in next slide. The second thing which is drastically happened in the case of the LLMs is better sampling. So by sampling I mean we know that the text model is in auto-regressive manner, that it generates next word. So by seeing the previous context of 100 words, I would be predicting 100 first word. Then my window would be from 1 to 101. Using this context, I would be predicting 100 second word, right? Now this predicting, what I am saying, it's not just one word would be predicted at random. It is again a probabilistic model. So we have a vocabulary, and within that vocabulary, the model will give that this word is most certain. The example what just Kuldeep was saying, cat sat on. It could be a table, it could be a mat, it cannot be a hat. So the probability to the word hat would be very less compared to the probabilities to the other words which are mat or table. So this sampling technique is, you can see it's very computational heavy because my English vocabulary is, let's say, around 100 or maybe 1000 words, just for simplicity. My dictionary has just 1000 words. Now at the decoding means, when I am predicting the word, within those 1000 words, I have to give probability to each and every word, and the most probable word would be the next outcome. But people have worked very hard to improve the sampling, that it is more smarter now in a nutshell. And two approaches is test time sampling, which it's like we are trying out several paths and we see which one is the most appropriate one, like cat sat on a table, cat sat on a mat, both would be generated, but we still see the aggregated probability, and based on that we will decide what is more appealing. And if you see in GPT, we have a parameter which you might have tried is the temperature, or if we ask to regenerate, still we get some variation. So this is possible because of the sampling approaches only. That okay, this sampling means this particular answer which was most probable, but it doesn't appeal to the user. When the next read run is done, we will take some other tokens which are less probable, and maybe that would be appealing to the user. So we have.
Let's say even the language changes drastically. So is it so what we had in Shakespeare time and what we have, let's say 10 years ago, and what now the Gen Z talks, they are very different things.
Right.
So even that context, someone trains again and again.
Again. So whatever it has seen so far, it would have that capacity, and some emergent abilities would be inherent. But like you're saying, Gen Z stocks, and if my model is trained till 2015 data, where Gen Zs were not that much using Insta and other social medias. So since it has not seen how they are talking, the nuances of their languages are not known. So maybe we can prompt the model to do something like this. It may do to some extent, but it won't be that confident in that.